as a service, quick and scalable machine learning POCs with no-code, low-code tools in the cloud. You joined AllCloud in 2020 as a pre-sales manager data, and you're developing machine learning solutions for industrial customers and previously worked as a data scientist at Deloitte. So it's a pleasure to have you here at our Big Data AI Summit. And for the next 20 minutes, the stage is yours.
Hello. Hi. Hi, everyone. Yeah, thank you for your introduction. So I think I don't need to add more to that. Yeah, maybe I start just with a little introduction of who I'm working for. So it's AllCloud, basically. And yeah, basically we are a professional service company and we are a premium partner of AWS. So we basically do everything in AWS. Yeah, and we have several competencies, as you can see. Yeah, we are the migration partner of the year. And yeah, we also have, yeah, for example, the ISO certification or yeah, the EU GDPR compliance certification. Yeah, that much to my employer, basically. Yeah. Today, I want to specifically talk about POC we did. And yeah, this POC we did was with KTM. Maybe you know them. It's a big manufacturer of motorbikes mainly. Yeah, and this POC was mainly about quality assurance of their frames. Yeah, all right. Yeah, so and in this production process, what's happening there? So they are building these frames of the motorbikes, and yeah, these frames have to be welded. And what can happen in this process that when some welding goes wrong, that there are spatters of this welding on the frames. And this is, of course, bad, and it has to be spotted. And this is done right now manually. Yeah, and the whole problem about this is actually, I mean, it just looks bad, of course, and it doesn't meet their standards, basically. And if you don't spot it immediately after the welding, the problem is after that the frame goes to the next station where it's basically painted. And in this process, so when it's painted, the frame, it's very clearly to see these weld spatters. So, and then you really see them, and then what you have to do is basically you have to remove the frame, the paint of the frame, and yeah, and then remove the weld spatter and then paint it again. So this is, yeah, this involves very high costs, and it's a lot of manual work. Yeah, and that's why they try to spot as many of these weld spatters as fast as possible in this process. Yeah, and right now it's done manually. And yeah, we made a POC with them, and we wanted to try out if we could automatically detect these weld spatters. And yeah, since they want to move very fast, we used basically an AI service of AWS, and this is basically what I want to talk about. This AI service is mainly Amazon Recognition. Yeah, and another thing what we had to do, because they had very little pictures just of these frames, so and we had to apply a process which is called data augmentation, which can basically increase your data set for machine learning. All right, so maybe I talk a bit more about these weld spatters and the challenge here. And here you can see such a frame, and in the circle there's one of these weld spatters. So basically we have pictures of such a frame, and we want to detect such spatters. Yeah, and in the future, they also want to look for different defects, for example, like holes, which can be created in the welding process. Then, for example, scratches can happen, dents, or even easy things like if they just miss to weld a certain part on the frame. So this is basically in the future we want to tackle also with the same technique. Yeah, some challenges of this POC were that, yeah, I mean, the lighting conditions were not very perfect. So you have, I mean, you can imagine it's like a hall where they produce all these frames, and yeah, it's quite changing. Then you have, I mean, the frames are made of metal, and so it's reflective, so it's quite hard to get good pictures. And yeah, another constraint was really that it has to be very fast, because these frames come like every couple of seconds, another one. So you just have a certain amount of time to check them. Yeah, and what was also very important for them, since they have all the time like new models of motorbikes, it was very important for them that you could quickly add to the model new pictures, and with very little pictures or very small amount of pictures, so that this whole process still works. Because sometimes they just produce like 80 frames of one model, you know, and it still has to work basically. Yeah, and their goals were really that we would detect every single defect. So yeah, everything basically what's afterward, it's completely perfect. Yeah, that's basically like the scope of this whole POC and the challenges. Yeah, so now I want to basically talk a bit more of the AI service we used and why it's actually great for such a POC if you just want to try out if something is working, or yeah, if not, and if you should maybe invest more time in that. Yeah, and AWS has this AI service. It's called Amazon Recognition. It's basically a low, no-code AI service, meaning that you don't have to code basically a single line of code. You can do everything in the console. This is what you can see here. So what you would do, you would take pictures of these frames, you know, and you need frames with the defect and without the defect. And Amazon Recognition specifically works for detecting a certain object in a picture, right? So what you have to do, you upload your pictures and you mark, basically data labeling, you mark where in the picture the defect is located. So and you do this for all your pictures, and then you just have to press on play, and in the background AWS trains a model for you. And after a certain amount of time, here I think it was like 10 hours training time, yeah, you have a model and it shows you your performance. Yeah, and if it's not enough, the performance of your model, you can just add more pictures, yeah, and retrain it basically. Yeah, so it's really quite a fast solution if you just want to try out something. Does this work? Is it worth for further investment? All right, but as I told you, they had just like, I think it was 10 pictures of frames which were perfect basically, and 10 pictures of frames which had a defect. And of course, if you ever had done some computer vision, you know that this is not enough, and it's also not enough for Amazon Recognition. So, and what did we do? So basically, we tried to create artificially new images, and this was done by rotating them slightly, by shifting them just in the image, like the image, yeah, you crop it basically, and then you could shift the colors, you know, or you can mirror it, you know, and with this, I think it's 5 different transformations. You can basically create as many pictures as you want. And of course, you always have to have in mind, okay, maybe the model just learns the pictures, so you have to be very careful by separating them, you know. But what we tried then, so step by step, basically, we increased the data set size, and we always checked, okay, is the test set still giving us good results, so that we don't have any overfitting or anything like that. And yeah, the cool thing, what happened, we started with 100 pictures in total. Yeah, and we just had like a precision of 70%. So basically most of the defects were not detected. But yeah, we increased it up to 10,000 pictures. And yeah, and we could reach then a precision of 93%. Yeah, which we want to further increase. But this is already quite a good result. Yeah. All right. That much to this use case, and yeah, it shows you how easily you can try out like ideas in AWS. Yeah, if you just want to see, okay, is something working easily? Yeah, and I think the total amount of this project was just like under 20 days, so it's really fast, I think. Yeah, and I think it's quite a cool thing. Yeah. What I also brought here, maybe some more material from us, which is also quite interesting. And I think you can download these if you get the presentation. I think you get it also online. Yeah, and one thing is here, like we made a market study. It's about machine learning in manufacturing. Yeah, then we also wrote a white paper about basically same topic, quality assurance. Yeah, and the last thing is basically an offer of us. It's a workshop, and yeah, it's mainly about, okay, you have maybe a couple of ideas of POCs which you want to do, and what we would do in this workshop. Yeah, we would, I mean, first think about like the business value. Okay, what would it get me basically if everything works out? But then we also look at the complexity. Okay, how much time is involved? How much do you have to invest? And also, okay, easy things like, is actually the data available for such POCs? And yeah, and then we can basically prioritize, and the outcome would be, for example, 5 projects which are really detailed out, which you could start on working after that. All right, I think we have a couple of minutes left, so we can make a Q&A.
Indeed, but first of all, thank you very much for bringing this case study. So yes, we indeed have a couple of minutes left for questions. So I'm looking at you in the audience if there are any follow-up questions. I see Stefano, so David can just quickly come over. We know who you are, so you do not need to introduce yourself.
Thank you. So would you consider a no-code environment just for a proof of concept? I mean, would you say that to get serious, one has to go in and start tweaking parameters all the time with code, or would it just somehow
be enough, basically? Yeah. I mean, it's actually really surprising how good these models are, actually. So, I mean, I don't know, but I think for the same thing, if we would have done it basically manually on our own, I think we would have spent minimum 2 or 3 times as much time on that to get just the same result. And everybody, I guess, knows that going beyond that, you have to add even more work into it. So I'm doubting that you could actually do it in... I mean, I think these services, make some use cases just possible to do, right? Because you would, if you would do it on your own, you would need to invest so much time, basically, that is not worth it anymore. That's what I think. I mean... And also to maybe talk about the downside, of course, AWS knows that, so these AI services are quite pricey, I have to say. So I think running like an instance where one of these models, I think it's like $4 per hour. So this can become quite expensive, yeah. But it's really... I mean, if you're really convinced that this is worth, you could then maybe invest the time, okay, because you know it really works, yeah, and build it on your own.
Thank you.
Thank you very much. We've got time for another question. But there is no question, so thank you very much. If there's questions coming up, feel free to say hi afterwards, because I know you'll be around for the rest of the day. And again, thank you very much for sharing your insights.